Hello everybody. I think that today is the day for a video on DMAG9b. So here is the manual for DMAG9b. It should be in the directory where you extracted the archive. And DMAG9b, oh, that should be a B here. DMAG9b is an implementation of the fast bilateral solver. And fast bilateral solver, let me see the paper. So that's the paper by John Barron and Ben Poole. Let's look at what's being solved. So of course the goal is to improve a given depth map. So this is the function that's being minimized. So let me explain. So T is the target, meaning that it's for a given pixel, that's the depth of that pixel, and that's given by your input depth map. So it's basically the grayscale value in your input depth map. So it is calling it the target. X is basically what you are solving for. So it's basically the new grayscale value for the depth map. C, that's the confidence. Okay, the confidence at a given pixel, obviously if it's 0, it means that you have absolutely no confidence in the T, and if it's large, it means you have high confidence. So what happens is that DMAG9b computes a confidence map, which I actually output. I think it's called hold on, let me go into that archive, extracted archive. So 9, so that's DMAG9b underscore test. So it's called con underscore map. That might be, yeah, it's a TIFF file. So I don't know why I put TIFF file, but okay, that's a TIFF file. Let's look at it. Yeah, this one is a bit very black. So anyway, anything white is high confidence, and anything black, if it's the blacker it is, the less confidence you have in the depth for that pixel in your input depth map. So basically the confidence map is going to be white wherever there is no change in depth, and as soon as you have a change in depth, it's gonna basically paint the pixel in some kind of grayscale value depending on the jump. So that's why you've got all those black lines here. So here you might have a uniform depth, then you have a drop or whatever, a change in depth. So you have another zone of white, and in between you're gonna have a curve which is darker. So that's true everywhere. So I mean, to control the width of those black lines, you have to play with the parameters, and those parameters are explained in the manual. I mean, you can look at it. This is the input. Anything that has to do with confidence map, radius, the gamma p, gamma c, and the sigma. Basically, the one that you may want to change, I don't think it matters that much, is the sigma. It's gonna make those black lines either wider or narrower. So I don't remember if you have to go up or down, but anyway, you can play with this sigma and it's going to change the look of that confidence map. So now let's go back to the paper. So if we go back to the paper, and here this is this term with the lambda, this is the smoothing term. What that term means is that you basically want neighboring pixels of similar color to be at the same depth. That's the big assumption in depth map generation. That's the big thing. So that's the idea. And here it's so this is like a bilateral filter. It's a faster version of it, but that's basically what it is. So what you want is that, so xi is the pixel that you consider, and the xg are the neighbors. So you want, basically you want to lower the value of that whole term. So you want neighboring pixels of similar color to have the same depth. That's the whole idea. So how did that come about, that idea that neighboring pixels of similar color should have the same depth? Well, in nature, usually if you have one object in the foreground and something in the background, usually the color of the object in front near the boundary is going to be different. Is going to be different from the color of the background near that boundary. So, for instance, if you usually if you have an object and you have a background, when you look at that at a picture in 2D, when you go near the border of the object in the foreground, there's going to be a change of color between the foreground object and the background. In general it's true, but obviously it's not always true. I mean, sometimes you can have objects at different depths having the same color, or you could also have an object with many colors, but everything is at the same depth. So it's kind of it's a big assumption, but it's usually what people assume when they write that kind of software. So if we go back to that equation, if the lambda is set to 0, so no smoothing of any kind, what's going to happen is that assuming that the confidence is high everywhere, the program is going to want to have x equal t to have a, because it's trying to minimize that whole function. So x equal t means that the output depth map is going to be the same as the input depth map, which is not very interesting. So as soon as you put the confidence, so now if you have a confidence, some pixels have a high confidence, let's say a confidence of 1, so that meaning that you really want the output depth map to keep that depth for that pixel. So some pixels are going to have a C which is equal to 1, high confidence, and some pixels are going to have a confidence that is low, let's say 0. And here what's going to happen is that if you don't have that smoothing term here, if for instance C equal 1, if C equals 0, so low confidence, X can take whatever, any value really. So the only way to control that X is by having that smoothing term here. So having lambda greater than 0. Otherwise, there's no way to control the X. So the X is controlled by that bilateral filter. The X is controlled by that idea that neighboring pixels of similar color should have the same depth. That's the whole principle that DMAG9b relies on, and what's explained in the paper relies on. So let's talk about the input file briefly, because the only way to know how it works is to try. So first line is reference image and the input depth map. So that's the depth map you're trying to improve. Spatial sample rate and the color sample rate. The spatial sample rate, I'm going to try to explain it in order to make DMAG9b the least aggressive in changing your input depth map. If the spatial sample rate is low, say like 2 or 4, and if the color sample rate is also low, your output depth map is very likely to be very similar to your input depth map. As soon as you increase those two rates, the output depth map is going to really diverge from the input depth map. So I think by default I use, let's see what I use. Okay. So this is the reference input. This is the spatial sample rate at 32 and the range color sample rate at 8. So if you lower 32, if you lower that spatial rate from 32 to, let's say, 8 or 4, the output depth map is going to look much more like the input depth map. And also, if this is set too high, the output depth map is going to look blocky. You're going to clearly see blocks in the output depth map. So if that bothers you too much, you lower that number. And also, this number, the spatial sample, depends on the size of the image. Here, my image, I think it's 1600 wide pixels. So I think 32 is okay, but you can go down. You can go down to 16, you can go down to 8. The color rate, so those two parameters, I think we're going to play around with them and see what impacts they have. Put depth map. The next one is the lambda. So the lambda is the one that we saw in the paper. That's this one, the smoothing, the factor for the smoothing term. So if it's 0, there's no smoothing. So the higher the lambda, the more smoothing is applied. So again, if you don't want your output depth map to be too different from the input depth map, you should lower that number. So instead of 0.25, you could use 0.025, for instance. The next one, the hash table size, you shouldn't really worry about it. Unless things get too slow, then you can increase it. 10,000, you can put 100,000. I don't think it's a big deal. Next one, don't care. Next one, don't care. Next one, don't care. And then it's all about the confidence map here. So radius, I think you can leave those even if the image size changes, but I mean, in theory the radius should be dependent on the image size, but I think you can leave those. And the last one, the sigma, controls how fat your the black bands are in your confidence map. I think we might play with that. We're gonna play with that number too, just to see. And then this is the output depth map. Other than that, I think it would be probably a good idea to read the manual. I think I explain in a little bit more detail what all those parameters mean. Yeah, so let's run what's on the DMAG9b underscore test and see the effects of changing a few parameters here and there. So first try. Okay, so this is the input, so that's the default, whatever. And I think first I'm gonna play with that one, the sigma on the confidence map. So let's run that one. That's gonna be our base result. Yeah, so it's just finished. It doesn't take long, maybe 1 minute. So I just want to look at the confidence map. Maybe I should show the initial depth map. Maybe this is the initial depth map. So that's your input depth map coming from DMAC5. So as you can see, there are a few problems here and there, especially like outliers, like here, and you know, the object boundaries are not very well defined. So that's something you may want to improve. I mean, and let's see what the confidence map looks like. So that's the confidence map. I'm gonna see. So let me load that into GIMP. Into GIMP. Where is GIMP? It's here. So that's my image. So let me load this guy, confidence map, so that we have a record of it. Okay, so now let's run. Let's change it. I don't know which way you're supposed to go, but so this was 2. Let's do 1 and see what happens. So let's run that one. I guess I can leave it. Okay, so let's run again. Okay, so it's done. So let's see what that new confidence map looks like. So let's load it into the GIMP where we already have the old one. So should be that one. Okay, so clearly it's getting fatter and fatter. So to sharpen a little bit your confidence map, you should go the other way. So you need to, instead of doing like 2, you need to go to, let's say 4. Yeah, let's run that one too, see what happens. Let's run that one. Get rid of this and let's run this one. Okay, it's done. So let's get rid of this. And again, the GIMP. So yeah, I also saved the output depth map corresponding to this confidence map. So now let's load up the new confidence map. This one. And let's compare that with maybe the original. So here, that last one, you are a little bit more confident about your depths. So we want to compare. Let's load up now the depth map, this one. Let's see if it makes much difference between this one and that one. So this one is with the 4 for the sigma, and this one is with 1 for sigma. Let's see the difference. So not a huge difference. Actually, I like that one better. Yeah, that one is probably better. So you can play with that stuff. And let's do something crazy here. Let's go even higher. Instead of 4 for the sigma, let's say 32. Let's see what happens. So let's run that one. Okay, so it's done. Let's go into the game and load the next one. So let's load confidence map first. Okay, so now you have a confidence map that says basically that all those pixels are very good. Only narrow areas are bad. So that's the difference. So let's look at the depth map. This one. Okay, so let's compare. So what you're seeing here is with using sigma equal 4, and this is with sigma equal 32. Almost no difference. Interesting. So I think sigma equal 4 is fine for this one. But let's continue. Okay, let's go back quickly to the GIMP. Yeah, when I talk about the depth map looking blocky, you can see the squares here. And if you look carefully, they should be 32 pixels by 32 pixels, which correspond to this number, 32. So if you want, you can reduce to 32. Let's do that. Let's try. Let's say we want to use 8. So you should get a depth map that's much closer to your original input depth map. So let's see what happens. So let's run again. Did I save? Okay, so let's run. Let's keep the 32. I don't think it matters. We could go back to a 4. Yeah, let's go back to 4. Doesn't really matter. But okay, let's go back to 4. And now let's run. Yes, so here I have just loaded the new depth map. So now if you compare, let's get rid of this one. Get rid of this one. So here I'm looking at that new depth map using the sample rate spatial equal to 8, and here I'm looking at everything else the same. The only thing that changed is that here I was using the default, which is at 32. So that's the difference. So first thing you notice is that you don't see those big giant blocks. And the second thing is, I think in general this depth map is actually better than the other one, even though that you still have things that are bad here. With sample rate equal 32, you get those weird things sometimes that you have a propagation where you shouldn't have propagation. But I mean, it's a balance between, it's really a balance. You really have to try different values and see which one you like the most. So I kind of like this one. So what I'm going to do next, I'm going to do the opposite. I'm going to on the color, I'm going to increase the bucket size to 32. So what happens is that the DMAG9b is going to deal with the fewer colors. So the depth map you're going to get should be further away from your input depth map. So let's run this one. Let's save. Okay, so let's run that one. Okay, so it's just finished. So let's load up the new depth map. This one. Okay, so this is with the sample rate for the color at 8. So it should be less smooth than the next one. This is sample rate at 32. So this is more smooth. Okay. Yeah, I mean, depends on your taste. I mean, you can certainly try different things. So yeah, so what I like playing with, I always do that. I like to go to try either 8 or 32 on both of them. You can try 16 also. So you play with those two parameters until you get something that you like. Note that when those numbers are lowered, it takes longer for DMAG9b to run. So keep that in mind. Yeah, so here I use 832. I think the default is the opposite. It's the inverse, 32 and 8. I mean, you can play around. Try 8, 16, and 32 for both 3 and 4 and see which one you like best. I think that's pretty much all you have to play with here in DMAG9b. So now let's I don't know, let's keep the last one. That's fine. That's the last one, and let's load up the input depth map, the one we started with, which is this one, I think. Yeah, so that's the DMAC5 depth map. So you go from this to that, or from this to that. What happens with the DMAC9b is that you really get a much better, a crisper depth map, and the depth map really follows the contours of objects. So that's what makes it powerful, I think. Okay, so I don't really have anything else to say about DMAG9b. The only thing I can say is that there's not one set of parameters that's going to work for everything. First of all, it really depends on the image, what's on the image, and second of all, it also depends on the size of the image, especially that 32, that sample rate for the spatial. Here I use from 32 to 8, but if you have bigger images you can go up to 64, and if you have smaller images you may want to go down to 4. I mean, it depends. Alright, so that's it for today, and I'll see you around. Bye.